Have you ever been working on a program, expecting it to perform flawlessly, only for it to suddenly halt and display a cascade of confusing messages? That unexpected interruption, that moment your code seems to throw its hands up, is often signaled by what we call a runtime stack trace error. A runtime stack trace error occurs when a program encounters an unhandled problem during its execution, causing it to crash and generate a detailed report of the sequence of function calls that led to the issue. This report, the stack trace, is essentially a snapshot of the program's execution history at the exact moment of failure, providing crucial clues for debugging. The fundamental mechanism behind these errors lies in the program's call stack. Imagine the call stack as a neatly ordered pile of tasks. When your program calls a function, that function is pushed onto the top of the stack. When the function completes its task, it is then popped off the stack, and execution returns to the previous function. Errors arise when this orderly process is disrupted, such as when a function is called infinitely without ever returning, leading to a stack overflow, which means the stack runs out of memory. Other common causes include attempting to access a memory location that does not exist or is invalid, known as a null pointer dereference, or trying to access an element beyond the boundaries of an array, which is an array index out of bounds error. Additionally, an uncaught exception, which is a specific type of error event that the program has not been explicitly told how to handle, will also propagate up the call stack until it causes a runtime error. To effectively use a stack trace for debugging, you typically read it from the top down. The topmost entry usually represents the most recent function call, the one actively executing when the error occurred. As you moved on the list, you trace back through the functions that called it, revealing the chain of events. Pay close attention to line numbers and file names, especially those within your own codebase rather than library functions, to pinpoint where your logic first went astray. The goal is to identify the first instance of your code in the trace that directly led to the problem. Understanding the concept of the call stack is incredibly powerful, transforming what looks like cryptic error messages into a navigational map. A stack trace is not just an error report. It is one of a programmer's most valuable diagnostic tools, providing an X-ray view into the program's state at its point of failure. Recognizing patterns in these traces, like recursive calls or memory access attempts, significantly speeds up the debugging process. By learning to interpret these invaluable reports, you gain a deep insight into how your program executes and where its vulnerabilities lie. This knowledge empowers you to not only fix immediate bugs but also to write more robust and resilient code in the future, building applications that stand strong against unexpected challenges.